Hi everyone, wish you a very good morning to all. So today we will continue our chapter number 4, light, reflection and refraction. So first of all I want to tell you about video, YouTube video. When you see this video, please check the quality of the video. Okay, 3 dots are given, there you can change the quality. Otherwise it will be 144, 240, it will not visible. So you make it 480, 720, so then it will be clearly visible. Otherwise you will complain that it is not visible and that. So please check the quality of the video. So in that 3 dots you can change the setting and you can see everything clearly. And when you see this video, please make the full screen. Make the full screen, then only you will see. Otherwise the words are not able to see. So when on the full screen it is visible. Okay, so that you can do. So here we are continuing chapter number 4, that is light, reflection and refraction. Yesterday I have sent one video and today you will see that. So here in this chapter, the light, that is a source of energy that causes sensation of sight. And here two important things we have to study, that is reflection and refraction. That all things I have discussed. And another thing regarding that reflection, the 2 laws of reflection, that is the first law, incident ray, reflected ray and normal ray. From the point of incidence, all lie in the same plane. And another law of reflection, the angle of incidence is always equal to the angle of reflection. Okay, so here these are the 2 laws that is very crucial for you. And about the refraction, it required 2 medium, and in the reflection it required only 1 medium. And today we are running with another topic. This topic already I have covered in the PPT presentation, and that will be combined with video also, and you might have seen that. So spherical mirror. Spherical mirror, there are 2 types of spherical mirror. There is a concave mirror and convex mirror. Even we are using plane mirror also. But we will discuss in the major form, that is concave and convex mirror. So yesterday all the terminology regarding this spherical mirror. First C was the center of curvature. P is a pole, R is a radius, F is a principal focus, and small f, that is a focal length. Even the line passed through the center of curvature and pole, that is a principal axis. So all terminology we have seen yesterday. And I want to go for another important topic. So when you come on the page number 218 in the textbook, so that is image formation by spherical mirrors. So here all students, I am requesting to write the definition of this center of curvature, pole, radius, principal focus, focal length and principal axis, with concave mirror and convex mirror diagram. With concave mirror and convex mirror diagram. So diagram you can see on page number 215. So 215, even you can see on page number 214 also. So that also you can draw. And so concave mirror and convex mirror, 2 diagrams you have to draw for this terminology. So this is what I am giving you. So first of all, definition you will write of center of curvature, pole, radius, principal focus, focal length and principal axis. All the definitions you have to write. Just the definition I am telling. No need to explain. Just the definition. And for your understanding you can draw diagram. Okay, it is not compulsory for all the students. For your understanding you can draw the diagram. So this is about the terms related to the reflection. Now here important topic we are going to discuss today in this video, that is image formation of spherical mirror. Image formation of spherical mirror. So here, as already we discussed, in our previous video, there are two types of images, real image and virtual image. So you must be clear when you will form the real image and when you will form the virtual image. So here, when we talk about the spherical mirrors, we'll take the first concave mirror. So in the concave mirror, first and foremost is it will form real image. It will form real image, and the position of the image is inverted. Position of the image is inverted. Clear? So here, first concept of the image formation of spherical mirror in concave mirror is they are formed real image and position is inverted. So real and inverted image we will form. Real and inverted. So the definition itself indicates the real image will form on the screen, but it will be inverted. So here real and inverted image it will be formed by concave mirror. Okay, so regarding that position wise, according to the position wise, also we will see at the particular distance. Some distance will be near the F, means principal focus. Some distance will be at the infinity. What type of image will form? Everything will see. But common is what? In the concave mirror, the image formation is real and inverted. Real and inverted. I am repeating. Real and inverted. Real and inverted. Now, when you come to the convex mirror, here the image is virtual and the position is erect. Okay, the position of the image means how it will form. So virtual and erect image it will form. Virtual and erect. So convex mirror, the image is virtual and erect. In concave mirror, the image is real and inverted. So real, so you can remember RI. And it is VE. Okay, so RI. Concave it is RI, and convex that is VE. Convex VE. So easily you will be able to remember. So R for the real, I for the inverted. So this is the position. This is the image formation. And in the convex mirror, virtual and erect image will form. So it is VE, V for virtual and E for erect. So if you see on page number 218, so image formation by concave mirror. So at here you can see 7 positions are given. Sorry, 6 positions are given. And behind that one image formation table also there. So everywhere the position is changed. If you see on page number 220 for this 220 page number, first see the table. The position of the object, position of image, nature of image and size of image. So here first you will see at the infinity it's very far. So here the position of the image will be at the principal focus. At the principal focus. And nature of the image is real and inverted. It will be common. And size of the image is very diminished. Very diminished means very small. Diminished means it is a word used to describe the image is very small. So that's why it is called highly diminished, means very small. So at the infinity, so position of the image is at the F, nature of the image is real and inverted, size of image is highly diminished. This you have to remember. Now beyond C means beyond the center of curvature, beyond the center of curvature, beyond that. So the position of the image is between C and F, between C and F, between C and F. C is center of curvature and F is principal focus. So image formation will be there between C and F. So here it is beyond the center of curvature. So image formation, the position of the image between C and F. Nature of the image, real and inverted, and size of the image is dimension, means small. Dimension means small. Next, at the position of center of curvature. Third, you can see the position of object at the center. Center means center of curvature, and the position of image, the object position at the center of curvature, and the position image at the center means center of curvature. That is real and inverted. Small size is that of the object, means as compared to object the size of image is small. As compared to object the size of image is small. Now you can see me right now. So suppose size of image will be somewhat smaller, okay, because it's it is one type of recording. So in that size of image becomes small. Then the position of the object, fourth number, the between the C and F, between the center of curvature and the principal focus. So here it is totally opposite. If you see second and fourth, image object and position of image, object and image, the position is interchanged. If in second beyond the C, then the position of image between the C and F. In position of object in 4 number between the C and F, so image is beyond C, okay, and image that is real and inverted and magnified means big image will be there. So same thing, if I will come near, so you will see the big image. If I will go far, then it will be small image. So same thing. Now next is at F. So first and 5 number. So at F you can see, please all students take support of your text. So then you will understand, otherwise what I am speaking it will be bouncing. So that's why it's my humble request, please take your textbook with you when you see this video. So at the F means principal focus. So image will be at the infinity. In first at the infinity and image is at F. Here object at F and image at infinity. So real and inverted, highly magnified is very big image, highly magnified. Next is what? The between F and P, principal focus and pole is image position. Sorry, object position. So image position will be behind the mirror. And here only one exceptional case, the image formation will be virtual and erect and magnified. Only one case. So in that, if it is beyond, it is between F and P, means principal focus and pole, image, the position of the object between F and P, the image will be behind the mirror. When the behind the mirror there, we consider as a virtual and erect, and size of the image is magnified. So all things I will show you with the help of PPT presentation. Everything will be clear in that. Right now I am trying my level best to understand the concept of image formation. So it is regarding the position of the object and position of the image. So position of the object we are using V, and position of the we are using U. Okay, so remember this is for the object, this is for the image and object. So if you come on page number 218, so first you will see when the object is placed at infinity. So here the position of image at the focus you can see, and size of the image is highly diminished, and nature of the image is real and inverted. You can see that diagram also, you can see that it can be asked in exam also. Draw a diagram which shows the position of the object at infinity. This type of question they can ask. Okay, and it has been asked in previous exams, so you have to remember. you have to prepare in each and every corner. Second is what? When the object is placed beyond the center of curvature. Beyond the center of curvature. So here what we can see, the position of the image between F and C. If you see in the diagram, you will see that position of the image between F and C, and the size of the image smaller than the size of object. And nature of the image is real and inverted. Okay. Now come to the third number. When the object is placed at center. So here the position of the image will be at the center, and the image is real and inverted, and size of the image, that is small, same size as the object. The object size will be same. So that I think in 2018 this question they asked, what is the image formation when the object will place at the center, in center of curvature? So it will be remain same. So fourth number, when the object is placed between C and F, center of curvature and principal focus. So here it will be very large, means as compared to object, the image is, if object is this much, this is the object, and image formation will be this much. So very big image will be formed. So nature of the image real and inverted, position of the image beyond the C, and the size of the image very large, means magnified. Fifth number, when the object is placed at focus, principal focus. So here the position of the image will be infinity. Infinity means very far, and the size of the image is highly and large, highly magnified. Magnified means too much big, because position of the image will be at the infinity. And the nature of the image, that is real and inverted. And sixth now, if the position of the object between F and P. So here the position of the image behind the mirror, size of the image will be larger than the size of the object, means little larger than the size of the object. So that all the diagrams you can see here. And what we discussed regarding image formation by the concave mirror. If you understand this table, the image formation, the position of the image, the position of the object, it's very easy. Please, again and again I am telling you, prepare this table, okay, and try to understand the concept. What is the concept? The position. What type of image? Size of the image is very clear. The nature of the image is very clear. Nature of the image will be remain same. Only in one exception case, beyond the C means it will convert into virtual element. Otherwise, remaining things are same. Now come to the page number 221. That is uses of concave mirror. Uses of concave mirror. Uses of concave mirror. Now first and foremost we know that concave mirror we are using headlights. In car headlights we are using, searchlights we are using, torches we are using, because it works as a reflector. In this equipment, bulb is placed at the focus of the concave mirror, and the light rays become parallel after reflecting from the concave mirror. So doctors are using concave mirror to concentrate light on the body parts like eye, throat, means very small organism they are focusing. Then concave mirror is used in the that is we can concentrated type solar cookers. In solar cooker also you will get the this type of mirror. That mirror is concave mirror. And another in the solar furnace, in that also we are using concave mirror. So these are the uses. They can ask easily what are the uses of concave mirror. So first use they are using in the car headlights, in torch. Second, if you see in the doctors are using that to visualize the small objects, small organs. And third is they use in the solar cooker, and fourth is they use in the solar furnace. Now in the image formation by the convex mirror, so here one thing is must be clear, that is virtual and erect. Here two positions will be there. First position, when the object is placed at the infinity. So you can see page number 222. In that it is mentioned, at the infinity, position of the image behind the mirror at principal focus, and nature of the image is virtual and erect. Many times I have repeated this word, virtual and erect, real and inverted, okay. So virtual and erect for the convex mirror, and size of the image is highly dynamic means very small. And next position, between the infinity and the pole. So here the formation of image, the position of the image behind the mirror between P and F. If any image will form behind the mirror, it's an indication it is a convex mirror behind. So what I am using, the behind the mirror, the image will given by convex mirror, and nature of the image is virtual and erect, and size of the image is very small, dynamized. Okay, highly dynamized means very small, microscopic type you can say, and dynamized means small. So this is the position of convex mirror in the object where we keep. So when you see page number 221, when the object is placed at infinity, the image will form behind the mirror, and the size of the image is highly diminished, and the nature of the image is virtual and erect. Clear? So this type of questions they can ask. And next is, when the object is placed anywhere between infinity and pole. Anywhere, it can be kept anywhere. So here also the image will form behind the mirror, in that they are smaller than the object, means diminished, and nature of the image is virtual and erect. So this is about the image formation by convex mirror. So one thing you must clear about image formation, here 6 positions are given in the concave mirror, and convex mirror 2 positions are given, and it is for virtual and erect. And here in 5 cases, so this position you will see real and inverted. In only one position, it means if you see the behind the mirror it will form, in that only it will come virtual and erect. Okay, sometimes students will make mistake because they are considering this part into the convex mirror also. So please be careful whenever they ask this type of question. Uses of concave mirror, and now we'll go for the convex mirror. Now uses of convex mirror, page number 223. So if you see, it used as a rear view mirror in vehicles like we are using. Bike it is there, so that is a convex mirror. And next in street lights also they are using as a convex mirror. Then big shopping complexes, they are using convex mirror are used to check the activities of customers in the stores, means that area will be enlarged, and it is used as a safety measure at dangerous corners. So in the dangerous corners also we are using convex mirror, so means it will show the each and every corner, so that's why this is used. And now few topics I want to discuss in today's video. So I think you are clear about the image formation by the spherical mirror, and these are the concept, these definitions you have to write, define these terms. Okay, and this is here, if I say, if you want to write, you can write the table of both concave and convex mirror, so it will be easily understood. Now here new Cartesian sign convention of spherical mirror. You can see on page number 223. Page number 223, new Cartesian sign convention for spherical mirror. So by looking at the object distance and image distance, the object distance and image distance. Object distance we are using, if you see in the diagram, so object distance we are using u, object distance, and image distance, image and object. This is distance. Okay, so distance of image we are using v, distance of object we are using u, so that you can remember. So here comes to the page number 223. So new Cartesian sign convention of spherical mirror. Now suppose this is our mirror and outside is reflecting. So here image will form and sometimes here image will form. So it depends on that. So distance are taken as negative because here it is a negative. If this side image will form here, if image will form here, so this will take as negative. But what is negative? What is negative? Image will take as negative. So image V is minus. Image will take as negative. And another thing, if image will form here, so it will take as positive. It will take as positive. And the distance are taken as positive. So here also you can see the distance taken. This, it is positive, this is minus. So that you will remember. So direction of incident, if you see the diagram you will get to know. So distance are taken as negative if it is minus side, and if distance taken as positive it is plus side. Then the distance of the y-axis and x-axis, if it is y-axis side it is positive, but minus y it is negative. So this is about the Cartesian sign, and you will easily see the sign convention of spherical mirror, page number 225. 225, page number 225, you will see the object distance in concave mirror and convex mirror. This you have to remember. Listen everyone, you have to remember. So object distance u, convex mirror is negative. So this is negative because image is forming. Image is formed this side. So it means object distance is negative in a concave mirror. And image distance V, image distance is positive. Image distance is positive. Image distance is positive. Image distance is positive. So here we can say object distance and image distance. So in concave mirror, image distance, object distance is negative, and convex mirror, the object distance is negative. Both are negative. Here both are negative will come. Both are negative. Object distance will be negative in both concave as well as convex. Please see here once again. The object distance will be negative in both concave and convex. Both negative. Object distance is negative. Object distance is negative in both concave and convex. So that you will clear. Then image distance V is negative and V is positive. So here we can say that V is negative for real image. and for positive it is for virtual image. So whenever image will be formed by concave mirror, it is negative. Image formed by concave mirror is negative, and by convex it is positive. Okay, so here image and object image. So here once again you please see that page number 225, the sign convention for the spherical mirror, the object distance u and image distance v. In concave mirror u is negative in both concave and convex, so u is negative, but in image distance v is negative for real image. V is negative for real image, and V is positive for convex mirror. V is positive means image distance is positive for convex mirror. So here we can see that this way. Here it will form this side and it will form this side. So it will minus and this is plus. Minus plus, minus negative plus positive. Then height of the object h1 h2. So that by completing this topic, mirror formula, this topic I am going to discuss now. Mirror formula. So mirror formula you have to remember this one. This is the mirror formula. So 1 upon f is equal to 1 upon v plus 1 upon u. So here u and v is image distance, the distance of image, and u is object distance. U is object distance and v is image distance. Once again, u is object distance and v is image distance. So here it is for the image and it is for the object. Vi and uo. Vi and uo. Vi, uo. Okay, like that you will remember. So 1 upon f is equal to 1 upon v plus 1 upon u. So 1 upon v, that is image distance, and 1 upon u, that is object distance. So this is a formula of image formation by mirror. So this is the mirror formula. So this is the mirror formula. 1 upon f is equal to 1 upon v plus 1 upon u. 1 upon f is equal to 1 upon u plus 1 upon v plus 1 upon u. Now here same thing. If lengths we will discuss in this chapter only. So here minus will come. When we talk about lengths formula, so it is there in this chapter only. So mirror formula plus sign will come, and the lengths formula minus sign will come. So 1 upon v plus 1 upon u for the mirror formula, and lengths formula 1 upon v minus 1 upon u. So that is for the lengths formula that we will discuss. Now here another thing that we will discuss, that is magnification. So magnification depends on the height of the object. If height of the object, that is image, and the height of the object. So here height of the image, that is h2, and height of the object, that is h1. So it is for image and this is for object. So h2 is what? Height of image. h1 is what? Height of object. Once again, m is a magnification. So h2 upon h1. h2 upon h1. The magnification of mirror. Magnification by the mirror. So m is equal to h2 upon h1. So h2 is the, we can say it is a image, the height of the image, and h1 is height of the object. So here, and if you by terms of the object distance u and the image distance from the pole of the spherical mirror, the magnification will be minus p upon u, minus v upon u. So here this is minus because image height is more than object. That's why it will come Cartesian sign minus. So m is equal to minus v upon u for the mirror magnification. It will be mirror magnification. So minus v upon u, minus v upon u. So here, if you see, for the concave mirror, m is equal to h2 upon h1. So that is positive. So h1 is positive, h2 is negative. So therefore, here in case of virtual image formed by the concave mirror, both h1 and h2 are positive. So therefore, because virtual image is erect, hence m is also positive. Then convex mirror. So convex mirror, m is equal to h2 upon h1. So therefore, it is 1 if here h2 is equal to h1 is equal to h2. If h1 is equal to h2, h1 is equal to h2. So therefore, h2 upon h1, here it is what is mentioned, h1 is equal to h2. So h1 upon h1. So it becomes 1. So m is 1. So in that condition, and second is if h2 is greater than h1, h2 is greater than h1, so that time it will come m is greater than 1. If, say, next condition, if h2 is less than h1, so m is less than 1. Okay, so these are the some important things about the magnification. If it will be same, so again and again I am telling you, just try to understand. If height of the image is greater than height of the object, so that time m is greater than h1, m is greater than 1. That is first second condition. Then h2 is less than h1, so m is less than 1. And third condition, both are equal, so m is 1. Okay, so vice versa both, so that time it will be 1. So this is condition. So this is about the magnification. So here, by looking at this, the sign convention for the spherical mirror. So whenever I will get time, when you come to the school, again I will try to revise everything. So don't worry about it. So here, the object distance u, image distance v, height of the object h1 and height of the image h2, then magnification m and focal length f. So if you see in the concave mirror, the focal length is negative, and the convex mirror, the focal length is positive. Focal length, why it is positive? Because it is forming behind. Okay, that's why. So this is about the magnification, new Cartesian sign. New Cartesian sign, once again try to understand. If it is minus sign, so image formation or object formation plus, and if it is plus minus, or if it is plus side, it will be plus. So here also height, the distance between, so that also plus minus. If it is this way, minus. If it is up, minus, plus. So simple thing. If I explain in my words, to try to understand. Suppose object is here, and this is a mirror. Okay, so image formation. If it is this side, if it is this side, and if it is this side, so here we can consider plus, here we can consider minus. So here it will come negative sign, here it will come plus sign. Okay, this is the image. This is also image. So image will form this side. So it becomes positive. If image will form at minus sign, so it becomes negative. The same thing, the distance between them also y minus 1. So if it is upward plus, if it is downward minus. Okay, this is simple thing. In this way you can understand. So this is about the magnification. So your work today I am giving you to write the definition of that terms. Second, that is image formation by the spherical mirror. The table you will write, that is page number 220. The image formed by the concave mirror, and next you will write about page number 222. The image formed by convex mirror, and then you will come for the table, the sign conversion for spherical mirror. So that also you will try to complete. So this is your work today, and if you want to go for NCERT questions, examples, you can also go for it. Okay, so once again, whenever I will get time in offline class, I will try to revise everything. So once again, we will have some brief introduction of this chapter. So, but you are at home right now, so you have more time to understand the topics. So please, it's my humble request to all of you. Please see all the examples. I am not telling you to write in the notebook, but try to understand. So here, if you see example 1, the radius of curvature of a concave mirror is 20 cm. Calculate the focal length. So here we can say the f is equal to 1 r by 2. So here the radius of the curvature, because of using sign convention, the focal length is negative. If you see in the first, if you see above table, the focal length of a concave mirror, please remember, the focal length of concave mirror is minus. Focal length of a concave mirror is minus this. Once again, the focal length of a concave mirror is minus, and for the convex mirror is plus. Focal length will be minus for concave mirror and will be plus for convex mirror. Okay, so by looking at this concept, we will try to solve the different numericals also. So these are the different numericals you can try at your home, and if any problem there, whenever offline classes will be start, that time we will try to clarify. So these are the topics we have discussed today. So once again I want to revise everything. So chapter 4, light, reflection and refraction. In the topics we have discussed, that is terms regarding the reflection, the laws of reflection, and today's topic, image formation by spherical mirror, concave mirror, once again real and inverted, convex mirror, virtual and erect. But when we talk about the sign of convention, so in the concave mirror, focal length is minus, in the convex mirror, the focal length is plus. Then new Cartesian sign. So by looking at this, you can understand if it is minus side, so the image or object will be negative, or if it is plus side, image or object will be plus. And according the same, the distance also, if it is upward direction, image formation, so it will be plus. If it is downward direction, it is minus. So image, for the distance of image we are using v, and distance of object we are using u. Distance of object u and distance of image v. So vi, just remember vi, I for the image. And the mirror formula, 1 upon f is equal to 1 upon v plus 1 upon u. So here v is what? Image, u is what? Object. Then magnification m is equal to h2 upon h1. h2 is what? The height of the image, and h1 is what? height of the object. But as far as mirror is concerned, the magnification is minus. Magnification is minus. But formula is plus. Remember, this formula is plus, but magnification is minus. Now three conditions when H1 is equal to H2 or H2 is equal to H1, so magnification will be 1. If H2 is greater than H1, magnification is greater than 1. Third condition, if H2 is less than H1, so magnification is less than 1. So these are the basic concepts regarding this new condition sign of convention, that mirror formula, magnification, and most important thing, they are asking what are the uses of concave mirror and a convex mirror. Concave mirror and convex mirror. Even in the NCERT question also there. So today your work which I have given to you, please try to complete. And in coming video, we will have another topic for the discussion. So it's my humble request all of you, please see it very carefully, understand, and if you have any doubt, then please note of it, and whenever the offline class will be there, you can ask me, or you can send me message also. I will try my level best to clarify your doubts. So thank you once again. Please see this chapter very seriously, because you have enough time at your home, so you can prepare, you can understand by taking more time. Otherwise, this chapter is very, you can understand what I mean to say. This chapter is very complex. If I speak this word, very complex, because right now we are talking only mirror. When the lens will come, it will mix up everything. Okay, so please, up to the spherical mirror, try to clear up it. Thank you. Have a nice day.